So, what is linear? Any element whose output characteristic is a straight line graph is called a linear element. For example, a resistance. If we just try to draw the VI characteristic of a resistance, it will somehow look like either like this or like this. The output graph will be a linear one. There will be variations, but the variations will be linear, proportionate. The change of voltage and the current will be proportionate. So, that is what it is meant by a linear, and all the elements whose characteristics are ultimately of this shape will be called a linear element. Next comes the active element. Any element which does not need power supply, an external power supply, is called an active element. That means it has its own independent power supply, and for example, any generator, any cell, any source of energy, anything that basically creates energy is an active element. And last, the bilateral element. So, what is a bilateral element? To understand the bilateral element, let us take two examples, one of a diode, another one of a resistance. What happens when someone applies a voltage to a resistance? As we can see from the diagram, there is a resistance of R and there is a voltage source of value V, and they are in series, and depending on the proportion of V and R, there will be a current flowing through the circuit whose value will be V by R. It is a very basic law called the Ohm's law. Now, if I change the polarity of this voltage source, that means if I change the polarity like this, what will happen? The amount of current that is going to flow in this circuit will be same. There will be no change in the amount or in the waveform of the circuit, of the current in the circuit, but what changes is the polarity. For example, in the previous case, the current was running something like, in this case the current is running like this, and in the previous case then it would have been running like this. So, as you can see clearly, only the polarity changes due to the change of applied voltage's polarity, nothing else. So, these kind of elements are called a bilateral element. Now, what is an unilateral element? Now, for example, take the example of a diode. What happens when you apply a voltage source and a diode in series? There are two things, one is called the forward bias, another one is called the reverse bias position of the diode. What happens in a particular direction, that is called the forward biasing direction, if you apply a voltage source with a diode, the diode simply acts as kind of a short circuit, and it allows full flow of the current in that particular direction. But what happens when you reverse the polarity of the applied voltage? The change is something very drastic. What happens in the reverse direction? The diode will not allow the current to flow, not even a single microampere of current will flow in the reverse direction. So, that is what it is called a reverse biasing. In reverse biasing, there is no flow of current. So, if I compare the case of the diode and the resistance simultaneously, you will see while I am changing the polarity in both the cases, the resistance is acting quite differently compared to a diode and vice versa. While in case of a resistance, only the current is changing its polarity, not the waveform or the value, nothing is getting changed, but in case of the diode, the whole thing is getting changed. the diode is only allowing the current to flow in a particular direction, and in the other direction it is not even allowing the current to flow. So, that is the difference between a unipolar device and a bipolar device. In case of a bipolar device does not changes the direction, does not changes the waveform or the value of the current with the change of the applied voltage, or rather with the change of the polarity of the applied voltage. While in case of a unipolar device, the whole waveform, anything, it may change in a drastic way. It not only changes the polarity of the current, but it changes everything. So, that is the difference between a unipolar device and a bipolar device. So, let us recap once again the theorem. It states any network comprising of linear, active and bilateral elements can be approximated with an equivalent network like this, consisting of a current source and the two resistances in parallel. Now, coming to the point, what is this RL and what is this RL? So, RL simply means the load resistance. Now, as you are all familiar with, a load is nothing but a point or a device which actually is consuming the energy. For example, I am running some device using a motor. Now, this motor is consuming energy. The electrical energy is being converted in mechanical energy, and that mechanical energy is being used to do some kind of work. So, that is happening inside a load resistance, or simply a load resistance is the approximation, or in a way it shows the method by which the energy is being consumed. Any point where energy is being consumed may be considered as a load. So, in this case we are just denoting the load as a resistance. Why? Because see, in case of electrical engineering, the only thing which dissipates energy is called resistance. So, that is why we have approximated load using a resistance, and that resistance is called a load resistance. Now, there is a second thing, it is called the Rn, or the total internal resistance of the circuitry. Now, what is a total internal resistance? The total internal resistance is nothing but the absolute characteristic of the circuit itself. Why I am saying so? Because the total internal resistance is an inbuilt characteristic of the circuit. It changes only when the elements, the internal resistance elements are being changed or modified, or else there is no way someone can alter the total internal resistance of the circuit, and the whole dynamics of the system is partially, if not completely, it is partially dependent on this, the value as well as the alignment of this total internal resistance.